does everybody remember the sine squared theta plus cos squared theta equals 1 and where it comes from? Where does it come from? The unit circle. Okay, so this is provided on your formula sheet. I just handed out your formula sheet. So you're given this, but any variation of this you have to be able to know. And most people can do this by mental math. For instance, if I move the cos squared theta over to the right side, I get that sine squared theta equals 1 minus cos squared theta. You see how I'm getting this? If I move sine squared theta over to the other side, you see I get that cos squared theta is 1 minus sine squared. So you're going to use alterations of that formula. Same with you're going to get this formula on the formula sheet, but in AP Calc next year, you won't get any formula. You have to memorize all these things. So I'm showing you how you can actually come up with this. Sine squared plus cos squared equals 1. If you take this equation and divide it by cos squared, watch what happens. Divide both sides by cos squared theta. You see, sine squared divided by cos squared gives you the tan squared theta. And then so that's this one here. And then if you divide it this way, cos squared divided by cos squared gives you the 1. And then the 1 over the cos squared gives you the secant squared, right? And then, of course, you would know any of the variations of that, right? Same with this one. If you take sine squared theta plus cos squared theta equals 1 and divide both sides by sine squared theta, you see if you divide that way, you get the 1. If you divide that way, you get the cotangent squared theta. And then, of course, the reciprocal function of sine is the cosecant squared theta. Again, the ones that are in the boxes you're given. You can see it on your formula sheet. But the variations you'll have to know how to do. Okay, so write 1 over 1 minus cos squared theta in terms of cosecant theta only. So do you recognize what this is? Yeah, so 1 over 1 minus cos squared theta, that's equal to 1 over sine squared theta. And that is equal to cosecant squared theta. Because this is one of the variations here of this, right? So 1 minus that is equal to that there. Okay, so how do we do on our proofs? And so I advise doing the proofs in the textbook because then there's solutions on OneNote. Then you can see how they're doing it when you're first getting started. Okay, and I'm gonna take pictures of people's proofs and we're gonna analyze them and see what kind of marks they would get. And it's not so that you know, you're not supposed to feel bad about your proofs. It's for you to improve your marks as your proofs. Okay, so 1 minus cos squared theta over cos squared theta, and then the tan squared theta over here. So what do you want to do first here? Start with the left side, and then I heard change this into sine squared theta. So then if you get sine squared theta over cos squared theta, which is tan, and then you're done. Okay, so if you didn't see that, you could have separated this fraction. So I'm going to show you an alteration of this. Again, for doing these proofs, there's going to be many ways to do these proofs. So I'm just going to do this another way. You don't have to write this down. 1 minus cos squared theta over cos squared theta. Do you see? You could divide, you know, separate this fraction. Do you see what I'm saying? So I get 1 over cos squared theta minus 1. Or actually, you know what? I'm not going to write it as minus 1. I'm going to show my steps. Cos squared theta over cos squared theta. And what is 1 over cos squared theta equal to? Yeah. Secant squared theta minus 1. And what is that equal to? If you look on your formula sheet, that is equal to tan squared theta. So then I would have been done doing it that way, right? Right here. Right here. Variation of it, right? Okay, let's try the next one. So sine to the power 4 theta minus cos to the power 4 theta and sine to the power 2 theta minus cos to the power 2 theta. Okay, so what can we do? Which one's the more complicated side? The left. Okay, so I purposely put this as one of your examples because if you have never seen this before, you will not know what to do. So I'm going to show you this once, and then from this will be in your back pocket. So does anybody think they know what to do? What can you factor, though? You do have to factor. Yeah, yeah, this is a difference of two perfect squares, right? So this is the square root of sine to the power of 4 is sine squared theta in the first spot, and the square root of cos to the power of 4 is cos squared theta. And then, of course, one's going to be a plus and one's going to be a minus. And then, now do you recognize this identity right here? That's 1, but make sure you show that step. So this is now going to be 1 times sine squared theta minus cos squared theta. And then my last step, of course, is just sine squared theta minus cos squared theta. What does anybody know what this Greek letter is? It's delta, actually. You guys know the capital delta? Yeah. This is the small letter delta. Why? Wasn't it like a smaller delta? Yeah. So tan squared delta sine squared. It's actually kind of hard to write sometimes. Tan, when you're not used to it. Tan squared delta minus sine squared delta. Okay, so which side is hard? The left side's harder? I disagree. The right side's harder? Probably, because it's subtraction versus, yeah. So what do you want to do here on the right side? Okay. So sine squared delta over cos squared delta minus sine squared delta. Okay, and then what do you want to do? Common denominator. Okay, let's do common denominator. So that is a cos squared delta, and this is still sine squared delta. And then what do I get on the right-hand side? You get sine squared delta, cos squared delta. Yeah. Okay, then what do we do? If you set delta to whatever, that would be introducing a new variable, so you get an error. Even if you set it. Well, you shouldn't do that. They're gonna use thetas or x's. Yeah. So what should we do next? Yeah, factor out a sine squared delta. And what do I left with when I factor that out? 1 minus cos squared delta. And that's all over cos squared delta. Can you see where it's going now? So what do we need to do? Yeah, so this is going to be sine squared delta times sine squared delta over cos squared delta. Don't automatically multiply it in the same step that you're substituting 1 minus cos squared as sine squared. That's skipping a step again. Okay, so it's up to you if you want to separate them to make it look like the left-hand side, or if you want to make the left-hand side look at the right-hand side. It's up to you. What do you want to do? Left-hand side. Go to the left. Okay, so tan squared, that's a square, is sine squared delta over cos squared delta, and this is sine squared delta. Now, this may look the same, but it's not, right? Because I'm writing the left-hand side as two fractions multiplied, essentially. So the next step, I have to make it look exactly like this, right? So that is sine squared delta times sine squared delta over all over cos squared delta. So therefore, the left-hand side equals the right-hand side. Okay, so now we're going to do the next one. So 2 cosecant x is sine x over 1 plus cos x plus 1 plus cos x over sine x. Okay, so yeah, so watch. Don't get confused between the 1 minus cos squared x. That's not 1 minus cos x, right? It has to have the square for you to actually use some of these identities, right? Okay, so what should we do first? Common denominator. So what's the common denominator here? 1 plus cos x sine x. Yeah, make sure you use a bracket around the 1 plus cos x, because otherwise you're intending to be a bracket without actually writing it. So what do I get on top for the first fraction? sine squared x. Make sure you're not writing it as sine x squared. It's sine squared x. And then what do I get over here? Yes, you guys are too good. Yes, you have to FOIL it. It's 1 plus cos x times 1 plus cos x, which is not 1 plus cos squared x. Yes, it's going to be 1 plus 2 cos x plus cos squared x. Okay, and how did I get that? Because when I multiply that, that's going to be 1 plus cos x times 1 plus cos x. And so do you see I get a FOIL? First, I get the 1. Then outer I get plus cos x. Inner I get plus cos x. So that's how I'm getting the 2 cos x. And then last I get the cos squared x. Okay, so do you see an identity here? Okay, so you need to write that in. So that's 1. So that, well, you could put 1 there if you want, I guess. But somewhere you're going to have to, you can't do too much at once. So if you go 1, that this is equal to 1 in the next step, you could add it. And I kind of hesitate saying that, so then I say, well, maybe you should just write as 1 and then write the plus 1 to it. But anyways, so then you get 2 plus 2 cos x over 1 plus cos x sine x. Okay, so then what do I do? Yeah, do you see if there's something that's common to both? That should be like the red flag. I need to factor that out. So 1 plus cos x over bracket 1 plus cos x sine x. And then what? Yeah, you can cancel those binomials there. So then you're left with 2 over sine x, which is 2 cosecant x. I'm just going to go up here because I'm running out of room, which is 2 cosecant x. Therefore, the left-hand side equals the right-hand side. I could have also changed the left-hand side to 2 times 1 over sine x, then multiplied and got 2 over sine x, but that's the same thing there. Does anybody remember what this Greek letter was again? Phi. Phi. Okay, so sine phi over 1 minus cos phi and 1 plus cos phi over sine phi. Okay, so what can we do here? What can we do here? Doesn't the left side look like so similar to the right side, but there's just one little tweak you have to do, and then it's, what's that thing called? The conjugate. Remember I said if you ever get stuck, it's usually you can't see a factor that you need to factor out, or it's a conjugate. So here's the conjugate situation. So conjugate, so here's the thing about conjugate. So I know you're trained that the conjugate is the denominator. It doesn't have to be the denominator. That's just because you were rationalizing the denominator that we ended up finding the conjugate. So you could find the conjugate of 1 minus cos phi, or you can do the conjugate of 1 plus cos phi. It's up to you which conjugate you want to deal with, either or you'll get the right answer. That's where you take the binomial and it's the opposite sign of it. So the conjugate of 1 minus cos phi would be 1 plus cos phi. And the reason why you have a conjugate is when you FOIL it out, the outer and the inner cancel each other. Right? Okay, so which one do you want to do? You want to do the left side? Okay, I have more room on the right side, but anyways, okay. So sine phi over 1 minus cos phi. Then you have to multiply it by 1 plus cos phi over 1 plus cos phi. Everybody see what I'm doing? Yeah. Okay, so here's the thing though. Do you see on the right-hand side I have 1 plus cos phi? Do you see I have 1 plus cos phi on the left side now? Does it make sense for me to multiply sine phi into both of those? What is that left? No, because I want 1 plus cos phi there. Do you see? This is where I'm saying you look kind of 2 steps ahead. So do you see? Because I want the 1 plus cos phi, don't multiply this in, because you're going to be factoring it out in a second if you do that. Yeah. Okay, so on top I get sine phi bracket 1 plus cos phi. Make sure you use brackets, otherwise that'll be an error code. And in the bottom, you get the FOIL. So then you get 1 minus cos squared phi. That's the whole reason of the conjugate, so that the outer and the inner will cancel when you do the FOIL. And so then that should be an identity you know. And what's that? That's sine squared. So then you get sine phi 1 plus cos phi over sine squared phi. And then what happens? I can cancel one of the sines with one of the sines, yes? And that's a legit move. 1 plus cos phi over sine phi. And then that is equal to the left-hand side. Or the right-hand side. Okay, so I want you guys to try this, and I want you to try this, and I'm going to take some pictures of people's work, and then we're going to analyze it, okay? So somebody's saying, tell me which side to start on. Well, yeah, the left looks way more complicated. But is it really? I don't know. I guess you'll see, hey? Okay, so I'll give you a second to do that. Okay, so let's see how this person did here. Okay, so it has to be clear for any marker to know what's going on here. So I'm going to use red here just to say, and also when you're doing this, just so you know, if this is a 4-mark question or a 3-mark question, every time you do an identity, you're gaining like a half mark. So even if you can't solve it or prove it completely, you can try to get as many points as you can. So for instance, him changing this to this, he's getting points here, right? He's already gained some points by doing those identities. Same with this here and this here. He's got some points. So he got, like, say, 1 mark already, right? Okay, so then he got a common denominator and put it together. So that's how he got this there. So it's easy to follow, right? And then he multiplied this, and so he's gaining another half mark by doing that. Okay, and then okay, hold on. So where did you go from there? Did you go down? Or did you go across? Okay, so you skipped a step. So you shouldn't have, so you will not get full marks at this point. So he wrote equals 1. You have to actually write the step. So I'm just going to put it right here. You should have it as 1 over sine squared theta cos squared theta over 1 over sine theta cos theta. So you have to go to this step, and then you can go to this step. And yeah, that's what I'm trying to say. You're gonna lose marks. So then he did the actual divide, and technically that's okay what he did, because you can do the flip and multiply at the same time for this, right? But then he showed his step. Of course, he didn't do too much at once, so that's good. Then he canceled those, right? Canceled those, and that's how he got that. And so then on this side, he got a common denominator. See, you actually showed the step where it equals 1 there, so I don't understand why you didn't on there.
I didn't think that would happen on purpose.
Okay, so I would say this is a 3.5 out of 4 or 2.5 out of 3, just a half mark just because you didn't do one of the steps. Okay, so let's go to the next one. So I don't know. So here is the next proof of somebody doing it. So again, it's clear what he's doing. He's changing cosecant squared to 1 over sine squared and secant squared to 1 over cos squared. Very good. And also the bottom changing to that, so that's good. So he's gained a mark there by doing those. Then he put this together as a common denominator, right, over that. And then he wrote it as the 1 on top. And he, you know, basically altered the division into multiplication, which is okay. So then he multiplied it, then canceled, and he got that. So that side is looking good. And then over here, everything looks good. So I would say you would get full marks there. So good. This almost looks the same, except what happened? What would you say based on looking at this here? She didn't, yeah, she didn't show this. Yeah, so this step right here, see the problem, and this is why I make this a point of this. I am not certain, and I know she did this because she skipped a step, but I'm just saying when you're marking in a provincial exam, you don't know these students at all, right? And so I'm going to be marking the same way. I do not know if she literally, because there are some students that would think that 1 over sine squared plus 1 over cos squared is 1 over sine squared cos squared. Do you see what I'm saying? They actually think that's a legit move, and it's not, obviously. So you have to show me that this actually, the step between, that this is sine squared theta plus cos squared theta over sine squared theta cos squared theta over 1 over sine theta. I don't have enough room here, but you have to show that step so that I can see that this is legitimately what you got when you added it together, that's how you get the 1. It's not because you don't know how to add fractions here. Do you see what I'm saying? That's why you have to show every step. So, which is funny because you did show the step here to go to 1. So, yeah, so again, not full marks, you'd get deduction of probably a half. I'd have to see how much marks I'm giving for that step there. I would have a rubric, so. Okay, so the next one here, a little small, maybe I'll make it bigger if I can. I don't know if I can make it bigger here. Hold on. Yeah. Okay. So let's see here. How do we do? So I have cosecant. Okay, so that's just the writing of that. Okay, so do you see in the second step what's happening here that you'll have to lose some marks? What's the mistake right here? Right here. Huh? Yeah, just magically cos squared theta happened and sine squared theta happened out of the blue. Yeah, if you put it on the top, you got to put it on the bottom. Otherwise, you'll get docked marks because you can't just throw that on there. That's like scrap paper work, right? I know what he's doing here. He's trying to get a common denominator, and he knows he has to multiply the top by cos squared and that by that. But it has to be both a form of 1. It has to be a form of 1, or don't show it at all. Like, you don't need to show that, right? That should be out of there. Okay, so I would have to dock something for that. And so then, of course, then you get to this step here where you're adding over that, over that. So does anybody see another reason why he would lose marks? This would be an error code here. Right here. What did he write? He wrote sine cos. What did he forget? He needs a theta in there. That's an error code. Well, so the good news for that person is it's an error code. So it's a half mark total for omitting. But so he would still get the proof right. He'd lose marks for the proof for this, but he would get the error code on that. Okay, so anyways. Okay. So then he goes from here to here, which is fine, and flips it, which is fine. He cancels that, which is fine. Then he gets it as that, which is fine. And then he goes to the right-hand side. Instead of writing it as 1, he goes to the right-hand side, which is okay. But then what did he do wrong on the right-hand side? He did the same thing again. He did the same thing again. Do not do that. That is not legit.